Hello everyone. Here's homework 25, factoring trinomials, and this is the basic situation. We first define a quadratic trinomial to be anything that takes this form of ax squared plus bx plus c, where we have to assume a, b, and c are real numbers, but more importantly where a is not 0. Because if a was 0, the squared term would be out, and we just have a linear expression. But what makes it quadratic is the squared term. Now, a couple examples. The 3x squared is our squared term. The 4x is referred to as the linear term, and the number alone is referred to as our constant term. But you could see in this example that basically a is 3, b is 4, and c is 1, if you needed to define those. Then we have a second term, second expression. This is quadratic as well. Again, you could tell because of the squared term. And then 3x in this case would represent the linear term. And the number itself, the negative 4 in this case, represents our constant term. And once again, you could define, now a is the coefficient of the x squared term, and in that case it's equal to 1, because it's understood. And b is 3, and c would be negative 4. So we look at the basic case, and the basic case is when a is 1. So instead of ax squared, it's just simply x squared, and then plus bx plus c. So recall how we use the FOIL method to multiply two binomials. We have the product here of x minus 3, a binomial, and x plus 5, a binomial, and we use FOIL. So the product of the first, x times x, gives us x squared. Product of the outers, x times 5, 5x. Remember, we don't write x5, we're at 5x, and we have to make sure we separate the terms with the sum or difference, so it's positive, so plus 5x. The inner terms, negative 3 times x, negative 3x, and then the product of the last, negative 3 times 5, negative 15. But then notice, as we have seen in the past, that the outer and the inner terms, that is, in this case, the 5x and the negative 3x, can be combined. There's no other x squared, so we rewrite that. And combining the 5x and the negative 3x, we get 2x, so plus 2x. There's no other constant term, so we just recopy the negative 15. So our goal basically is to reverse this process, starting with a quadratic trinomial. We want to be able to express it as the product of two binomials. Okay, so essentially, where did it come from? It's almost like Jeopardy, right? Here's the answer, what was the question? So, I didn't say always here. Here's the idea, though. The general quadratic trinomial can often, okay, there are cases where it cannot be factored into the product of two binomials. So we make that assumption basically when we go through these problems. The first few questions here are kind of nice to get us warmed up. They're giving us one of the binomial factors. That is, they're saying that x plus 2 is a factor of this quadratic trinomial. So what we could think of, so it says here to complete the factorization and check using FOIL, what we could think of is basically foiling this. How would these terms look such that when we FOIL out this product of two binomials, we get this quadratic trinomial? Well, with one of the factors filled in, it's rather easy, because you could say to yourself, we need x times something, which is the product of the first. Because remember, when we're doing FOIL, this is F, O, I, and L. But the outers and the inners in the quadratic trinomial are the combination. That's the middle term, is the combination of the outers and the inners. So therefore, we can think of forcing the first to give us the x squared. And the only thing we could put in here would be an x, and that would be the product of the first. And then we could think of forcing the last. Let me do it this way. I'm going to leave some space for an arrow to my x here. But forcing the product of the last to produce positive 6 in this case. And the only choice, because this is the last term, see, these are the outers and the inners, the 5x. And so, since this is a positive 2, the only choice to multiply to give positive 6 would be a positive 3. And then we could check this using FOIL. Product of the first is x squared. Okay, here's the outers. X times 3 plus 3x. Here's the inner terms. 2 times x plus 2x. And then our last that we calculated plus, or that we forced, basically 2 times 3 is 6. And then when we combine the outers and the inners, we have the plus 3x and the plus 2x, which gives us positive 5x. And we bring down the plus 6, and that checks, because that is the original expression. So the answer is the product of x plus 2 and x plus 3. So same thing here, but a little bit different because of the signs. But to begin with, notice that because the squared term is just x squared, when we take the product of the first, our only choice here again is x. And that's going to become important when we're not given what one of the factors is. And we'll worry about the outers and the inners later. This will be the outer product. This will be the inner product. We'll worry about those later. But the question I'm asking myself here is for the product of the last. They have to give us, because again, the x squared represents the first, the 18 represents the last, the negative 9x is a combination of the outers and the inners. And so, in order to produce a positive 18, what we want to do here is take this negative 3 times what is going to give us that positive 18. Well, see, I would need a negative to get a positive. And 3 times what is 18? That would just simply be 6. And so, checking this using FOIL, product of the first, x times x, x squared. Okay, here's the outers, x times negative 6, negative 6x. Here's the inner product again, negative 3 times x, negative 3x. And then the product of the last, the negative 3 times the negative 6 is a positive 18. And we can combine the outers and the inners again. So we recopy the x squared, a negative 6x and a negative 3x combined to give us a negative 9x. And then we've got the constant term just recopied. And you can see that that checks as well, because that is the original quadratic trinomial. Okay, so now we have to be able to do this without the hint, okay? Without being told what one of the factors is. So, a little remark here from our experience using FOIL. We see that the outer and inner terms combine to give us the middle term in this quadratic trinomial. So the outers and the inners produce the middle term, the bx in particular. So here's the procedure. And this is when a is equal to 1. We're going to reverse FOIL. Kind of like what we just did. But we're not going to be given the hint. But one thing we could do for sure, because this first term is x squared, is set up the factorization to be the product of two binomials, where the first term of each binomial is just going to be x. So that the product of the first here is going to give us the x squared. So algebraically, this is what it looks like. So we immediately start by doing that. And then we force the product of the last terms to be equal to the constant term c. So again, this is the product of the first. These numbers here will be the product of the last. And we're just going to force that product to be equal to that term c. And then we're going to check. Okay, so first thing is to set it up, then force the last terms, and then check. And you're checking in particular to see that the outers and the inner product combine to give us the bx term, the linear term. And there's actually, for this case, although I'd like you to consider the reversing FOIL method as we've just described, for this case, there's a little trick that always works, but it only works when a is equal to 1. We're basically looking for two numbers that multiply to give us c, and add to give us b. So these two numbers here multiply 2 times 3, which is 6, and that's the value of c. And they add, which is basically the inners and the outers, add those two numbers, 2 plus 3, and we get 5, which is the value of b. So that's a little trick that's often used when a is 1, but only when a is 1. When a is not 1, that rule does not apply. So we're going to look at a series of examples. And it says factor the trinomial. Whenever we see a quadratic trinomial, the first thing we should think of is factoring as the product of two binomials. So we set it up, and if the leading term, the squared term, is just simply x squared, that is, the coefficient is 1, there's nothing written out in front of the x squared term, it's understood to be 1, then immediately we just fill in the first term of each binomial to be x and x. And then we want two numbers that multiply to give us 12, that add to give us 7. And so you have to think of the factors of 12. The factors of 12 are 1 and 12, a -1 and a -12, because that's the factors of positive 12, a 2 and a 3, I'm sorry, a 2 and a 6, a -2 and a -6, or a 3 and a 4, or a -3 and a -4. So we're looking for the pair of factors that add to give us this middle term 7. And so you can see in this case, it's going to be the 3 and the 4. Now, you didn't need to really run through all of that. You could have just used some tricks here. In terms of reversing FOIL, if these signs are all positive, there's no way to generate a negative. So you know those must be positive. So we force the first terms to be x squared. We just want these two numbers to multiply to give us 12. But at the same time to add to give us 7. So a good guess, I mean we did it over here, but a good guess would be 3 and 4. And the reason it works is because the inner product is 3x, and the outer product is 4x. So let me do it this way. So the inner product gave us 3x, the outer product gives us 4x. I'll put a double line there, and then if we combine those, we get 7x, and that's what we're looking for the outers and inners to combine to give us that. So therefore we know the correct factorization is x plus 3 and x plus 4. Alright, now this factor thing works well, but I like to think about how we force the first, x and x, and then we're going to calculate the product of the inners and the outers. Combine those to give us -8x. Now a couple things about this one. In terms of the signs, in order to multiply to give us a positive 15, but at the same time add to give us a -8, these terms would both have to be negative, because that's the only way we can multiply to get a 15 here. Now, we're going to use trial and error, is what I'm going to suggest, because when we get to the situation where the leading coefficient is not 1, trial and error is required. So let me say I guessed, let me get some scrap paper out here. Let me say instead of the correct numbers, let me say I guessed, there's not many choices, right? And there's 15 times 1 and 3 times 5, that's it. Let's say I used 15 and 1, and I knew both had to be negative. If I check the inner, that's negative 15x. If I check the outer, that's negative 1x. They combine to give negative 16x, which is wrong. We don't want negative 16, we want negative 8. So therefore, 3 and 5, and it doesn't matter the order, you could put 5 and 3. And we would check the inner product, that gives negative 3x, and the outer product to give negative 5x, and they combine to give negative 8x. So therefore, which is what we're looking for. So therefore, the correct factorization is x minus 3 and x minus 5. Now once again, the factor thing works. Here, let's list the factors of 15. Again, you have to account for both positive and negatives. So 1 times 15, negative 1 times 15, 3 times 5, negative 3 times negative 5. So amongst those factors, we're looking for the pair of factors that combine, that add together, right? They multiply to give us 15, those are the factors of 15, that add together to give us the negative 8. And we could see that would be this pair, the negative 3 and the negative 5. Okay, so if you want to exclusively use this method of the factors, that's fine. I'm going to be showing this little trial and what I call the trial and error method, where we force the product of the first and we force the product of the last, and then we check that the outers and then the inners combine to give us that middle term. Okay, so, and the more you do this, the better you get. Sometimes, you know, you're calculating these inner and outer products mentally. I'm going to first do this, and then we'll I'm going to do it the trial and error method, and then we'll show the factors. Now, one thing about this, last term being negative, is that when I place to produce the product of negative 24, one of them will have to be positive and one of them will have to be negative. So, as opposed to the, you know, earlier cases where they were both the same sign. And I'm going to guess at two numbers that multiply to give 24. Now, typically, it's not going to be the extremes. Like, look at this, when we listed these factors. It could be, but typically it's not. So I'm going to guess instead of 24 and 1, 12 and 2, I'm going to guess 8 and 3. Now, let me show you one thing. If I put, and I'm going to put this on scrap paper, if I put the x plus and the x minus, and I'm going to guess an 8 and a 3. If I put the 8 over here and the 3 over here, when I check this, that gives positive 8x for the inners and a negative 3x for the outers, which combine to give us a positive 5x. But notice that I'm not looking for a positive 5. We're looking for a negative 5. So therefore, all that means is that we have to switch the 8 and the 3. So it's going to be x plus 3 and x minus 8. And now we'll check the inner product plus 3x, the outer product negative 8x, and they combine to give us negative 5x, so that checks. I'll just put little check marks there. I probably should have been doing that all along. So the correct factorization, x plus 3, x minus 8. And you may have to do some side work like I've been doing on the scrap paper there. And I'll continue to do that, but I'm only going to put the correct answer in our notes here. I'll go to the scrap paper for some of the ones that we try. See, now I want factors of negative 24. So there'd be 1 in negative 24, or negative 1 in positive 24, 2 in negative 12, negative 2 positive 12, 3 in negative 8, negative 3 in 8, 4 in negative 6, negative 4 and 6, and then you look amongst the list and you want the pair of these factors that add to give you the negative 5, and it looks like the 3 and the negative 8 would do it, and so you can see that's what we ended up with. Alright, we'll do one more and then we'll cut this video into 2 parts. Because we have another page after this one, so we'll make a 2-part video here, but let's just finish up number 4. Okay, what we're seeing is all the different situations for the signs. Okay, the reason why I'm doing it this way rather than just exclusively by the factors is because it's very important to realize that this factor method only works for when the leading coefficient is 1. The reverse FOIL that I'm showing you is the way that everybody factors by trial and error. But remember, we start every problem the same way. You see a quadratic trinomial, 2 binomials, x and x. Now the signs, if you want to account for the signs. If this is a negative, if the constant term is negative, these terms are going to be opposite signs. Plus, minus, minus, plus, it doesn't matter. If the constant term is positive, like example 1 and 2, then the signs are going to be the same, and they will be positive if the middle term is positive, and they will be negative if the middle term is negative. So those are some things to keep in mind. Although, if you don't keep those in mind, you'll still be successful here. Now I want 2 numbers that multiply to give me 10. So instead of a 10 and a 1, I'm thinking a 2 and a 5. And once again, like here, let's try all the possibilities just for the fun of it. What are the real possibilities? Let me do the plus and the minus here. A 1 and a 10. Right? Check the inners, 1x, the outers, negative 10x. They give negative 9x. There's no way, even if I switch these signs, they would just produce a positive 9x. I'm looking for a 3x, so that's no good. My only other choice is 2 and 5. So x and x, do a 2 and a 5. Let me put the positive here and the negative here. I'm going to do it wrong. I'm going to put the 2 with the plus and the 5 with the negative. And watch this. We get 2x is the inners, positive. That is, the negative 5x is the outers. Combining, we get negative 3x. We're looking for the positive 3x. So therefore, switch the signs. So instead of 2 being positive and 5 being negative, make the 5 positive and the 2 negative. And then check. 5 times x plus 5x. for the inners, x times -2, -2x for the outers, combining, get a positive 3x, and that's what we're looking for. So the correct factorization, x plus 5, x minus 2. And again, you could do the factor thing. So list the factors of a -10. So 1 and -10, -1 and 10, 2 and -5, -2 and 5, and that's it. And then we're looking for the pair of factors that add to give us positive 3. And so, looking amongst the list, the -2 and positive 5, and you can see, of course, that that's the same that we got by the trial and error method. Okay, so we'll cut this video at that point, and we'll come back and finish the rest in part 2.